All right, today's lesson is on describing graphs. Okay, so it says how to describe a graph. This is in your classwork packet. And so we're just going to start talking about some different ways to express what graphs look like and some of their characteristics. This is really important as we're going through Algebra 1 this year. So I want to make sure that we all kind of have some of the same lingo or terminology. Let's look at the first one. It says, answer the following investigation questions. Okay, so we've got this graph, and they want to know, what does it look like? Is it increasing or decreasing? Is it a function? What is the domain? What is the range? Is there a line of symmetry? What are the x and y intercepts? And are there any special points? Okay, so get used to those questions because you're going to get asked those a lot, and you're going to have to analyze a lot of graphs and give feedback about them. Before we get started with this one, let's just go ahead here and add on to our graph some arrows. They should be on there. I forgot to add them on. Okay, so this isn't some crazy trick question that we're starting with. It says, what does it look like? Just give me some sort of description of what you think it looks like. Usually what I hear on this one is it kind of looks like an S. It is shaped like an S. So it's shaped like the letter S. Now, is it increasing or decreasing? Well, to determine that, remember, we have to read our graph from left to right. So as we are following our graph, like if we started here on this side, as we're like reading the graph, looking from left to right, okay, you'll see that if I trace this graph, I'm going upwards as I'm going to the right. So that means when we're going up to the right, we are increasing. All right, then we reach this point, and then we're still going up as we're going to the right. I got a little steeper there for a second, but this is still all increasing. It's going up to the right. So we could say here, this graph is going to be increasing. Right, so we'll say it increases from left to right. Okay, so as we go to the right, it's going upward. Okay, is it a function? Well, great thing to do with this one, right? When you think about functions, because it is a graph, we could take it here and we could do our vertical line test. Right, if I take my little vertical line that I have here, right, and let's take it here, and I'm just moving it here, it is not crossing this graph in more than one location, right? It gets up here. Now it gets a little steep in the middle, and it might be hard to determine there that, oh, are there points above and below each other? But I'm going to tell you that there actually aren't there. And then as we continue up here, it only intersects our graph in one place. So, yes, this is a function. Okay, you could even list on there it passes the vertical line test. Okay, what is the domain? Well, with the domain, remember we got to focus on the fact that I made you draw those arrows on the ends of this. So, let me just move out this line so it's not in the way. If we're going to go to the left forever, remember domain, we're talking about our x-axis, all the x coordinates. If it's going to the left forever, we know that what we'd get to out there is negative infinity. And then the same thing on the right side, if it's going right forever, we know that this is going to be a positive infinity. So we could say that our domain is going to be from negative infinity to positive infinity, and we'll say it in inequality form. Negative infinity is less than x, and x is less than positive infinity. Okay? Or we could also call that all real numbers. Now with our range values, notice since this one is still going this way, even though it looks like it's going more left, it's still going downward. And as this one's going to the right, it's still going upward. So since there are no breaks and it's going up and down with arrows, we know that the range is also all real numbers. So negative infinity is less than y, and y is less than positive infinity. Or like I said, you could call it all real numbers. Is there a line of symmetry? I don't believe that there is a line of symmetry on this one. There is no line that we can take it and like draw in there, and it is a direct reflection of itself across that line. So no line of symmetry. It says, what are the x and y intercepts? Well, the only place it crosses the x and y axes is right here at the origin. So the origin is going to be our x-intercept and our y-intercept. So x-intercept is 0, 0. Our y-intercept is at 0, 0. And then are there any special points, min, max, vertex? Not really. We do call this point right in the middle a point of inflection, but we're not to that point in your math careers yet, so I would say not on this problem. No special points. Okay, hopefully that's making sense. I'm going to move it up here to look at number 2. First thing it says is, what does it look like? Okay, so what does it look like? Well, this shape is what we call a parabola, and we'll learn about that a little bit more this year. But it, kind of looks like an upside down hill, or I'm sorry, it looks like a hill that's the correct way, right? Or an upside down U, or V, or like a lowercase n, however you wish to describe it there. And so, looks like a hill, or a frown face, right? It looks like a frown, something like that. Okay, now, is this one increasing or decreasing? And actually, I forgot to put, let's put some points on this down here, right? This one doesn't have arrows, it's got points on the end. I just forgot to put them on before I printed it. So increasing or decreasing? Remember, we read this from left to right. So as you go from left to right, is it increasing or decreasing? So let's just trace it with our pencil. Okay, so as I'm going from left to right, it looks like I'm going up. So this one's increasing until we get to right here where x is 5, right? So we could say it increases until you get to x equals 5. And then what happens here? Now it looks like we're going downhill, right? So when you're going down, you're decreasing. So it's increasing until x equals 5, then decreasing. All right, so if you need to jot like notes on there, right? This is increasing. So you're going left to right. And then this one is decreasing. Right, because you're going down. Is it a function? Yes, it is. This one passes the vertical line test as well. What is the domain? And this is why I had you put the endpoints on there. So looking at the shadow that's cast there, our point farthest left starts at 1 and goes all the way to 9, and there's points all the way in between. So this graph covers on the x-axis from 1 to 9. So our domain is going to be from 1 to 9. So we'll say 1 is less than or equal to x, and x is less than or equal to 9. Our range values, well, we find our lowest point, right? So our lowest points are down here. So that'd be down at, say, -9. And then it goes all the way up to 7. So we're just going to say here, we're going from -9 is less than or equal to y, and y is less than or equal to 7. Is there a line of symmetry? If so, where? I believe that we would have a line of symmetry on this one, right? If we took this and we kind of split this shape in half, it's going to have a reflection across that line. So we'll say yes. Now we have to talk about what is this line. Well, this line is the location where all of the x coordinates are 5. So we'll say yes. We'll say it's where x equals 5. It says what are the x and y intercepts? Okay. Well, it doesn't look like this one touches the y-axis, right? Because here's your y-axis way over here. It's not even touched. So it does touch the x-axis, though, right here and right here. We might just have to kind of estimate it. So we'd say our x-intercepts are, let's see here, about 2.25. And over here, maybe let's say about 7.75. Okay, because it's definitely between 7 and 8. Are there any special points, mins, max, or vertex? There actually are. When we look at this, right, there is a highest point right here. So we'd say our max is the point 5, 7. Which is going to also be our vertex. Actually, let me explain there. I didn't explain that. Mins versus maxes there, right? Min means minimum or lowest point. Max stands for maximum, and that is our highest point. All right, let's move on. Number 3 says, Riley is impressed with Lydia's graph of a cube root function. He wants to impress her in return by graphing an absolute value function. It says, create a table and graph for the function y equals absolute value of x. Then answer the questions that follow. So we're going to look at this function, y is equal to the absolute value of x. So we're taking each of these values and plugging them in. So we're going to think about absolute value of negative 7 would be 7, right? So we can fill those in. So that would be 7. This one should be 6, 5, 4, 3, 2, 1. The absolute value of 0 is 0. Absolute value of 1, 2, 3, 4, 5, 6, 7 would all be themselves. So we can take those and we can plot them on the graph. So we have negative 7, positive 7, negative 6, positive 6, negative 5, positive 5, and so on as we work our way down to 0, 0, and then we climb our way back up. I will go ahead and connect those. What does the graph look like? I would say this one is a V shape. Is it increasing or decreasing? Well, as we trace with our pencil, right, it's going down right now, so this would be decreasing until we get to 0, and then it looks like it's going to end up starting to increase. Right, so on this side we've got decreasing. On this side it is increasing. So we'd have to say both on that, right? We'd have to say both. And you can describe on there if you want to, right? It decreases until x equals 0. Then increases. Is it a function? Yes, it is. It would pass the vertical line test. What is the domain? Well, since we've got arrows on the ends, right, we know that it's going to go out towards positive infinity to the right and negative infinity to the left. So we'd say negative infinity is less than x, and x is less than positive infinity. The range does have a bottom, right? We've got a bottom down here, and then it looks like it would go up forever. So we'll say in this case then it's going to go from 0 is less than or equal to y, and is less than positive infinity. Is there a line of symmetry? It does look like there's a line of symmetry right where this pink one that I drew in. There's a reflection across there. So we'll say yes at the line y equals 0. I'm sorry, x equals 0. What are the x and y intercepts? In this case, it's like that first one we have there where the x-intercept is 0, 0, and the y-intercept is also 0, 0. Are there any special points? Well, we have a vertex at 0, 0. And that would also be a min, right? That would also be a minimum value because it's the bottom point. And then it says, are there any values of x that you cannot use in the equation above? If so, what are they? I don't believe that there are any that we could not use in the equation above. Right, we could plug in anything in there and take the absolute value. Okay, so I would say no. You can take the absolute value of any positive or negative number. And then the last question says, are there any values for y that you will never get when you evaluate the equation? If so, what are they? Well, if you look at it there, right, our graph goes down to the x-axis and then back up, but we never have any points down here below the x-axis, right? So we will have no outputs less than 0. And if you notice there, 0 is the smallest number in our range. All right, so that's just a way of describing some of the graphs. So hopefully if you're not in class and you're trying to keep up with some of the notes and things there, you'll be able to follow along with that. We're going to do a lot of practice. I'm not expect you to have it memorized and mastered right away. It'll take some time. So just as long as we're working to build that understanding, that's all we need to be doing.